Have you ever wondered about the intricate dance between glucose absorption, metabolism, and the common table salt, sodium chloride? Could these seemingly disparate elements be more interlinked than we've previously known? Welcome to an exploration of this captivating topic. Diving into the world of glucose absorption, it's essential to understand that this process primarily occurs in the small intestine. Here, glucose is transported across the intestinal wall by a protein called SGLT1, a sodium-glucose cotransporter. Interestingly, this process is heavily dependent on the concentration of sodium ions found abundantly in sodium chloride. A study published in the Journal of Biological Chemistry explains this phenomenon in detail. According to the researchers, the SGLT1 transporter works by using the energy from the sodium ion gradient to move glucose against its concentration gradient. In essence, the higher the sodium concentration, the more efficiently glucose can be absorbed. Moving on to glucose metabolism, a process known as glycolysis, it involves the breakdown of glucose to produce energy. This process is tightly regulated by various factors, including insulin, a hormone that promotes glucose uptake by cells. But where does sodium chloride fit into this picture? A fascinating research paper from the American Journal of Physiology sheds some light. The study reveals that high salt intake can lead to insulin resistance, a condition where cells become less responsive to insulin, impairing glucose uptake and metabolism. This suggests that sodium chloride indirectly affects glucose metabolism by modulating insulin sensitivity. Now, let's summarize what we've learned so far. Glucose absorption in the small intestine is facilitated by the SGLT1 transporter, a process that relies heavily on sodium ions. On the other hand, glucose metabolism, regulated by insulin among other things, can be affected by sodium chloride intake, influencing insulin sensitivity. These findings remind us of the intricate balance that governs our body's functioning. The elements we often take for granted, like the salt in our food, can play significant roles in essential biological processes, such as glucose absorption and metabolism. As we continue to unravel the mysteries of our body, we realize how interconnected everything truly is. So the next time you reach for that salt shaker, remember, you're not just adding flavor to your food. You're also playing a part in the complex symphony of your body's biochemistry.